This is lesson 10, distance on a coordinate plane. All right, we're going to find the distance between the 2 points using the Pythagorean theorem. So the first thing that we need to do is to create a right triangle for these 2 points. Okay, so the first thing that we can do here is we can draw a line that goes here and here to make our right triangle for right here. Okay, so here we can have A that goes from here to here, which would be 3 units. Then we can have a triangle that goes from here, and here would be 6 units. Okay, that would be our B. Here would be our A. And then here would be our C. Okay, so then the next thing we can do is to label the hypotenuse with 3 and label A and B, which we just did. Okay, let me first bring this into focus just a little bit better there. Okay, and bring this in there. Okay, so step 3 is says to find the distance in units, exact and to the nearest tenth. So now we have 3 squared, because we have our formula right here, plus 6 squared now is going to equal C squared, because we don't know what that is. So now we have 9 plus 36 equals C squared. So now we have 45 equals C squared. So when we take the square root of both sides, and it says to find the exact and the nearest tenth. So our exact here, 45 would be 9 times 5 is 45. So we could have 3 square root of 5. Sorry, first we've got to take the square root. So the square root is square root of 45 equals C. So the exact would then be 3 square root of 5 equals C. The other is the approximate. Okay, and the approximate then, with our calculator, for the square root of 35 or 45 would be 6.708203932, and to the nearest tenth would be 6.7. Okay, so next, the example 1, it says, is the triangle formed by the points A, B, C a right triangle? Well, if I draw this, and we draw the points here, and let me move this up so you guys can see this. I'm sorry. We have here, and then we have across here. So we have this triangle. We're trying to see if it's a right triangle. So now if we have this, we have the 3 sides of a triangle. We have the height here, which we would have is 3. This would be 1. This whole cross would be 9. So what we could do then is find the 2, add them together, and see what we have. So we have, first of all, we have this triangle. So we have A squared plus B squared equals C squared. So we have 1 squared plus 3 squared equals C squared. So we have 1 plus 9 equals c squared. 10 equals c squared, or the square root of both sides. So c equals the square root of 10. Okay. Next we have 9. So a squared plus b squared equals c squared. So now we have, and what we found here was c. We found here the c part of ac, which is this right here, the square root of 10. So we're now finding this side here. We're finding c here is what we're finding. So we've got a, which is 9 and 3. So we have 9 squared plus 3 squared equals c squared. So we have 81 plus 9 equals c squared. And we have the square, or 90 equals c squared. So the square root of 90. Okay. So c to b here would be the square root of 90. So now what we need to do is find out to see if we have a right triangle. Okay, so now what we need to find is the a squared plus b squared equals c squared. So now I have the square root of 10 plus the square root of 90. And does that equal 10 squared? Because remember, the hypotenuse is always the longest side, okay? And that's what this is right here. So now we've got, these are squared. So now I have 10 plus 90. Does that equal 100? And here we have 100 equals 100. And yes, that is a right triangle, though it may not look it, okay? Though it may not look it, it is a right triangle, okay? And actually, if you move it, okay, you would be able to tell that it is a right triangle at one point, okay? So next. Now, example number 2 says, from the above problem, okay, we see that you can measure the horizontal distance between the points and the vertical distance between the points, and then use the Pythagorean theorem. So in other words, we can use c squared equals the horizontal distance squared plus the vertical distance squared, and c would equal that square root of the both of those added together, okay? So we do have, again, a formula for that, and that's called the distance formula. So the distance between the points A and B is the square root of, in parentheses, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, so for example, if I have 2 points, okay, if I have 2 points here and here, I can find the distance between these 2 points without having to find the triangle by simply using the points themselves. So if I were to find these 2 points, here's my x-axis, here's my y-axis, okay? So my x-axis, this point here is 2 and 1. So my x value is 2, my y value is 1. This value up here is 5. If I count over 1, 2, 3, 4, 5, my x value is 5. My y value, if I count up, 1, 2, 3, 4, 5. So these 2 points, here are these 2 points. So if I were to find, using the distance formula, what the distance would be, here's how I would find that. So my distance would be underneath my radical symbol. And again, I can pick either one, x2 or x1. So I am going to use my x2 for 2. So I'm going to use 2 minus 5 squared plus 1 minus 5 squared. So now I have equals, all of this stays under the parentheses. 2 minus 5 is negative 3 squared plus 1 minus 5 is negative 4 squared. So now, again, we're still under the radical sign. Negative 3 squared, so negative 3 times negative 3 is 9, plus negative 4 times negative 4 is 16, which equals the square root of. So 9 plus 16 is 25. So the square root of 25 is 5 units. And that would be my distance. Okay. And that is our lesson for today.